Welcome friends, welcome you all in my channel Chemistry, the Mystery of Molecules. I am Tanma. So today we will discuss a question which I have collected from internet, and this question is Luche reduction of this compound, what will be the product? Okay, 4 options are given. Now to solve this question, this question may come a 2 marks question, means you don't need to think more. But if you know the fact, you can explain it very easily. So, for such type of question, I can tell you the answer, but you should know what is Luche reaction. No reagent is given, only name is given. So that's why it is needed to learn that these name reactions. I have made a video about Luche reduction. I'll add the link at the first comment. So I suggest you, please have a look at that. You will have a detailed understanding about Luche reduction. So here, without losing much time, I will say what is the reagent. Reagent is cerium 3 chloride, sodium borohydride and methanol as a solvent. So this is the reagent, and what is its unique react character? It reduces selectively ketone in presence of other groups like aldehyde. Okay, in presence of aldehyde and ketone both, it reduces selectively the ketone into secondary alcohol. Second point, that is also important, alpha beta unsaturated ketone you take, so it will reduce selectively the ketone carbonyl group, not the alpha beta unsaturated, that is double bond. So this is the uniqueness of this Luche reduction. So up to this, you can say what will be the product. Here, so if you get such type of question, I suggest you check what are the functional groups available or functional groups given for this problem. For example, one functional group is this, that is ketone, this is aldehyde, and this is ester. So what is the primary criteria for Luche reduction? Ketone. So it will be reduced. So where ketone is reduced? 2 options. Option B and option D. What is the difference between B and D? In option B, aldehyde not reduced, but here reduced. And we told that in presence of ketone and aldehyde, this ketone is selectively reduced. So means this will be the answer. So this is very easy. You can solve this question within 30 seconds. Okay? Okay. So those who don't know about Luche reduction, I will give a little explanation about it, why this reaction is selective to ketone. More details, please go through my video about Luche reduction. What happens in presence of this cerium 3 chloride? I'll clean this part. In presence of this cerium 3 chloride, methanol and this sodium borohydride, actually here sodium borohydride is pre-reagent. It's converted into some another reagent. For example, this cerium 3, in presence of cerium 3 as a catalyst, sodium borohydride is converted into sodium boro. It's a mixture of hydride. Actually, what is said, this is N, this is 4 minus N. Actually, this mixture of borohydride is formed, and this hydride acts as a reducing agent. And generally it is written, in problem you may not found this general, you may found that sodium HbOMe3. This is the actual reagent for reduction. And if we check the carbonyl compound, what happens? This carbonyl group do not bind selectively with cerium. What? Cerium produces here hard center, that is, this is oxygen contains lone pair, and we know that carbonyl is a form, canonical form where oxygen is negative and this. So these indicate that carbonyl group, this positive charge density here, negative here, that's why it likes to form hydrogen bond with the proton from this methanol. But this hydrogen bond initially is not that much stronger. What happens? Cerium is a lanthanide, it coordinates with oxygen. And we know lanthanides are very strong Lewis acid due to the lanthanide contraction which arises due to the electron filling on the outermost f orbital, which poorly shields the nuclear charge. That's why these ligand electrons are strongly attracted towards the cerium center or lanthanide center, which makes them strong coordination, and consequently, if more electron density goes from oxygen to cerium, and oxygen is electronegative element, so means its electron density is going somewhere. It will not like. It will try to take electron density from other sources. What are other sources? This OMe bond and this OH. OH is more polarizable because a significant difference in electronegativity. That's why this polarization will be more. Polarization more means delta positive charge on oxygen more. I guess you have got it. So if the delta positive charge on hydrogen is more, then it will be attached to this carbonyl oxygen strongly based on this acid-base interaction. This is strong acid. Now it became stronger acid. This methanol cerium complex became stronger acidic than parent methanol. So now if this is strong, then it will bind strongly with oxygen, because this became hard. This became hard interaction. Okay. This is. Now what happens? This generated hydride, it has also a role. If you compare this with this parent sodium borohydride, you can see this. If hydride goes, which results in BH3, and if here hydride goes, results in BME3. BOME3. Is it visible? Yes, it is visible. So if we compare the stability of BOME3, we can see oxygen has lone pair and boron has vacant p orbital. So oxygen can donate its electron through this back bonding 3 oxygen. So here the boron stability will be little bit more compared to this parent BH3. And what is the real proof of this concept? BH3, is it difficult to find BH3? Actually BH3 remains its dimeric form, is equivalent to B2H6, where this boron has a 2 bridge hydrogen with 3 center 2 electron bond. I have explained in B2H6 or diboron video. So that's why it pushes more. This hydride goes attacks here. So due to the pushing effect, this hydride becomes stronger or harder nucleophile compared to parent sodium borohydride. That's why sodium borohydride can't achieve this, although it can achieve this. So in this way, this whole cerium, methanol and sodium borohydride generated reagent, that is sodium methoxyborohydride, achieve this selective reduction of carbonyl into a secondary alcohol. So this is the end of this video. So if you like my videos, please give a thumbs up and subscribe my channel Chemistry the Mystery of Molecule, and please press the bell icon to get the notification of every single video I upload. And last, I request you to share this video among your friends so everybody can get benefited from this effort of mine. So thank you everyone. See you in my next video.